All right, so number 5, part B, really similar to the last one. Again, we're just finding absolute max and min, and the process is the same. We have this interval, -1 to 2, and to find the absolute max and min, we need to check the endpoints of that interval as well as any critical number that is within that interval. So we always have to start by taking the derivative of our function and finding out if there's any critical numbers that we have to put in the interval. So first we're going to take our derivative, f prime of t. And with the function t times square root of 4 minus t squared, we're going to have to use the product rule to do that derivative because we have t times another function, and those are not simplifiable in any way. So since this is a square root, I'll treat that as 1/2 power. So by using our product rule, derivative of t is 1, and then we would just multiply by 4 minus t squared to the 1/2, plus we would have t now times the derivative of this. We'd have bring the 1/2 down, 4 minus t squared now to the -1/2, and we also have to multiply by -2t due to the chain rule. So this whole term right here is just the derivative of the square root part. So let's see what cancels out here. We get a 1/2 and a 2 that go away. T times -t will bring a -t squared to the front. So let's write that one more step before we simplify any further. So this would be minus t squared times 4 minus t squared to the -1/2. So after some simplification, this is what our derivative becomes. But in order to find critical numbers, we have to set this equal to 0 or see where it's undefined. The problem is that this is a negative power, so we essentially have a denominator on this term. So what we need to do is to get these two together in order to answer that question, and to do that we need a common denominator. So I'm going to rewrite this term. So this is 4 minus t squared to the -1/2. So really that's just 4 minus t squared to the 1/2, but on the denominator. And to get a common denominator, we just need to multiply this term by 4 minus t squared to the 1/2 over 4 minus t squared to the 1/2. Well, that's going to work out nice because in order to get this to be a common denominator, we have to multiply it by 4 minus t squared to the 1/2, which would get rid of the power because we'd be multiplying as a square root of something times the square root of something. We just get 4 minus t squared minus t squared over here, and our combined denominator was 4 minus t squared to the 1/2. So now this is one fraction, and we can actually do a little bit more simplification. This would be 4 minus t squared minus t squared is 4 minus 2t squared, and we could factor out a 2. All right, so what I've written there is just the most simplified version of our derivative, one fraction. So now we want to know when would this be 0 or undefined. So unlike the previous two problems, if the denominator here was 0, that would give us critical numbers, because if the denominator is 0, that wouldn't make this function undefined. So we have to consider both in this case. So where is the numerator 0? Where is the denominator equal to 0? So our numerator is equal to 0 when 2 minus t squared is equal to 0. In other words, t is plus or minus the square root of 2. Because if you put square root of 2 squared and then subtract these, you get 0. Where is our denominator equal to 0? That would be when 4 minus t squared is 0. In other words, t is equal to plus or minus 2, because 2 squared would give you 4, and that would be 0. So we have 4 critical numbers here. We have root 2 and negative root 2, and we also have 2 and negative 2. But remember that we're only concerned with the values that are within the interval that was given to us in the first place. So our interval is -1 to 2. So we can kind of get rid of both of these, plus and minus 2. Because first of all, negative 2 is outside our interval. It's further left than negative 1. And we don't really need to check 2, or 2 isn't important to us as a critical number because it was already our endpoint. We were going to be checking it anyway. So in essence, both of these are useless. And now let's look at plus and minus square root of 2. Well, square root of 2 is definitely in that interval, so we need to consider that. But negative square root of 2 is further away than negative 1, is less than negative 1. So that one we don't care about. So we don't care about negative square root of 2. So the only critical number that we got that is within our interval that's important for us to check is x is equal to square root of 2. So this is a good example of why you need to check all your numbers when you're doing absolute max and min problems, because it's possible that a lot of the critical numbers that you get are not in the interval that you were given, and in that case you don't care about them. So again, we got 4 critical numbers, but we're only even using one of them to do this. And one of them is one of the endpoints anyway. So now we just check those numbers. We're going to do f of negative 1, we're going to do f of square root of 2, and we're going to do f of 2. We're going to check all 3 of these, and then again, biggest one's the max, and lowest one's the min. So we're plugging these numbers back into our original function here. So f of negative 1, if we plug in negative 1 to our function, negative 1 squared would be 1, 4 minus 1 would be 3, so we have square root of 3, times negative 1, we get negative square root of 3. Square root of 2 is the next thing that we're plugging in, f of square root of 2. So square root of 2 squared would be 2. 4 minus 2, meaning we have square root of 2, times square root of 2. Square root of 2 times square root of 2 is 2. And finally, we're plugging in 2. Well, if we plug in 2 for t, 2 squared is 4, and this part becomes 0, so the whole thing becomes 0. So that one's pretty clear then. What's the max and min? Our max is f of square root of 2 equals 2. So 2 is our max value, and negative root 3 is our min value. Same process as before, but this time we got a lot of critical numbers that we didn't use because they weren't in the middle of our interval.
The Teaching Center, UF's Learning Resource Center.